Good day, everyone, and welcome to today's DevOps.com webinar. We're excited to have you here. We got a really interesting topic. We're going to be talking about running a cost-effective DynamoDB-Compatible database on managed Kubernetes clusters. I mean, Kubernetes and Dynamo and AWS, all very popular topics. I think we'll have a great time talking about this. Today's webinar is sponsored by Scylla, and my name is Mitch Ashley. I'm CEO of Accelerated Strategies, and I'm going to be co-host and also participating in some of the conversation. A few housekeeping items. We're recording the webinar, and all participants will receive an email with links to the recording as well as slides to download. So you can sit back, not have to write all those notes. Just jot down a few things, but the slides will come to you. You'll be in good shape. Also, we're giving away 4 Amazon gift cards. So we'll talk about those at the end when we wrap up. We love questions, so please enter those questions into the GoToWebinar software. And we'll be addressing questions during the webinar. Anything that we don't get to, we'll follow up with a email to contact folks who we didn't get to ask or answer their question. So let's move on to our topic. Running a cost-effective DynamoDB-Compatible database on Kubernetes, managed Kubernetes services. It's my pleasure to introduce today's speaker, who you see on video. But also, let's get our slide to turn here. There we go, one more. Okay, Moreno Garcia. Moreno, how are you doing?
I'm doing pretty good. How are you, Mitch?
Very good, very good. This is an interesting webinar because we're international, Brazil and Colorado, USA. So
absolutely.
Let's cross our fingers our internet connection stays up. So would you just give us a brief introduction of yourself and your solutions architect at Scylla and a little bit about what you do?
Well, I've been an architect for the past 10 years, the last 3 with Scylla. My job here is pretty simple. It's just make sure, people that are using Scylla are successful with it. And before they go and start using Scylla, making sure they have the right use case for us.
It always helps people get off on the right start. And that's usually what a solution architect is really focused on. So
absolutely.
Sounds like
even because when they start with the right foot, it saves me a lot of headache in the future.
Yeah, you don't have to back things up and kind of get restarted again. Well, you know what? So database technology has been around for a long time, and there certainly are some very popular databases. Non-SQL as well as SQL. First, one question I would ask you before we get into Scylla. Just give us a little bit of background of why build another database product? What was the niche or the need that you saw that let's go after this, let's create a great product that will address that need?
Well, I was not here in the beginning, but I know the story. So it started with our founders, among them Avi Kivit. He's very famous among kernel hackers. So they created the KVM hypervisor. At some point, the KVM hypervisor was bought by Red Hat. After they transitioned everything to Red Hat, they decided they wanted to, make more money and still have a lot of fun in the process, right? So they started looking at other markets. The NoSQL databases market was, incredible, lots of exciting stuff. But we had one advantage. We got a little late to the game, so we were able to analyze all the databases that were in the market. And we particularly liked the Cassandra architecture, especially from an outside standpoint. So, the idea of a highly available distributed database implementing, those concepts that everybody knows from the big table paper, the Dynamo paper. And well, because we got a little late, we were able to analyze the weaknesses of all those databases in this space. And we decided to rewrite everything and make sure that our engine would fix those problems that we were able to see in hindsight.
Early bird doesn't always get the worm, right? There's opportunity that creates, especially when a market is kind of proven and things continue to evolve. Well, why don't we get into Scylla? Let you tell us a little bit about it. Here's our agenda for today. we're going to talk about is why, and we give a little bit of the background there. Why and what is Alternator, things you're going to talk about. Why and what is Scylla Operator. And then we're going to have a demo. We'll kind of start it up in the middle of this to get it going, and then we'll kind of pick back up. But there's a lot of great capabilities on your website, I know. So we'll see. Well, interesting to see this demo. So is there anything else you want to cover here? I know you gave us a little bit of background on the how it started, but tell us more about ScyllaDB.
Well, so as I mentioned, because we kept that external architecture, we are dropping replacement for Apache Cassandra. We use the same, you can use the same drivers, the same connectors, no change in the application code. Even the admin tools are the same. So you use Node to run, maintenance operations on Cassandra. You use the same tool on Scylla. And then, of course, just recently we added the Alternator, which is API for the Amazon DynamoDB. So same thing. If you just point you have an application that it's written to run on Dynamo, you just point that application to Scylla and it works out of the box. And of course, I can talk literally for 3 days about Scylla because I'm one of the guys that delivers training, but there's a lot of reasons why we have better performance, not only throughput, but also low and predictable latencies.
We'll definitely get into that for sure. Open source is also part of your business model.
Absolutely. In our core, we are, open source guys. As I mentioned, it started with, kernel hackers. So everybody has open source in their blood, in their DNA. We're committed to the community, to our users, but of course, we also have to pay the bills. So we have an enterprise version. And now we have a managed service that runs on the cloud.
Well, I know it's important to all developers, especially DevOps folks, people that value open source. Makes a difference when you're really open sources in your DNA versus you kind of have an open source model. And given your Linux and KVM roots, kind of hard to dispute that. So, well, let's talk a little bit about why Scylla. Sorry to cut you off there, but let's talk about some more about why and what's the performance issues that people are running up against with Cassandra and where Scylla fits in that.
Yeah, so, we have a lot of reasons because we've rewritten everything from scratch, right? So one of the things that we are able to do is to use bigger and better machines for your nodes, so you're not stuck with commodity hardware. Second thing, we don't have a JVM. You don't have a JVM. You don't have garbage collection. And garbage collection is a stop the world kind of event, so you don't see those latency spikes. We're less complex. We don't have a gazillion parameters that you have to tune. And every time you change your use case or you add a new use case to the database, you don't need to play with all those knobs, to make it better again. It just gives you the best performance out of the box. And now I already mentioned we were compatible with the Cassandra API, so CQL. Now we're compatible with the DynamoDB.
Yeah, I am impressed. I'm interested to see the demo. I'm sure you're not going to show all of this, but that drop-in capability for Cassandra, that's pretty awesome because that usually isn't the case. There's usually some rip it apart, put it back together to drop in something as fundamental as a database. And the fact that you've maintained that compatibility with Cassandra, kind of taking it to the next step. Not in general.
Yeah, and this is something that I get on a daily basis. Sometimes users they come to a pre-sales meeting or to our Slack channel, and they ask, "Hey, if I point my application to Scylla, is it just going to work?" And I tell them, "You know what? You can run Scylla on Docker. You don't need a big machine just for functional testing." So they spin up a Docker container on their machine, point their development environment to that Docker container, and it just works.
Very cool. Should I go to the next slide? Talk a little bit more about Scylla?
Absolutely.
Great. All you. Go for it.
Yeah. So this is the things that we mentioned before. So the first thing is that, well, I keep telling people that we are not in the magic business. We are on IT, right? So sometimes when people look at our benchmarks, they go and think, how is that possible, right? We're not doing any arcane magic in the background. We are just using the resources that you provide us, as much as possible. So one point is being closer to the hardware. So that's the reason we chose C++ instead of other languages, among other reasons, right? Mm-hmm. And as we were developing the databases, we put most of the control inside the database. So we can leverage CPU, we can leverage all your memory, we can leverage, the full capabilities of your disk. We are completely asynchronous. We avoid, any type of contention as much as possible. And because of that, we scale linearly. And we're one of the few software out there that can, at some levels, bottleneck those mighty NVMEs that you see, popping up on cloud environments.
Mm-hmm. One of the questions we've already gotten is to talk a little bit about what are the kinds of applications that are going to kind of bring Cassandra to its knees and say, I really need something that's got better performance, lower latency, that kind of thing. I'm going to move this ahead too. I know your COMCAST is one of your customers. Maybe that's a good example to talk about.
Yeah, that's a great example. So they had 962 nodes of Cassandra. After they moved to Scylla, they were able to reduce that to 78 nodes. Big part of that is, those design decisions that we took with Scylla. So we are leveraging the full potential of each of those machines. The second part is just, you don't have to use small boxes with Scylla. Anything you have, let's say a big machine like an i3 Metal on AWS, we can leverage all those CPUs, all that memory, all those NVMEs.
So the multi-threading of the application is much better. It's a little trickier to do, I think, because Cassandra's in Java, right? A little trickier to do there.
Yeah, it's not just about the throughput, because I keep telling people, if you are Bruce Wayne or Tony Stark and you have infinite money, you can buy throughput with any databases, right? You just throw money at it, you buy more boxes, you buy more computing power. At some point, it's going to meet your requirements in terms of throughput. But for latencies, it's a different game, because there are two things that money cannot buy. That's love and good latencies. In order to have good latencies, you need two things. You need, good software engineering, and you need good hardware. So when you pair Scylla with good hardware, just like I mentioned, like the i3s on AWS, you're going to see those good latencies.
Well, I'm going to have to test you and Google that to see if it says latency. Two things that money can buy. So talk a little bit more. I mean, in the COMCAST example, and I know that they've given some talks about this, so it's not just you that talks about COMCAST.
Yeah, absolutely. They are very outspoken. They talked about this on our Scylla Summit last year. I keep telling people I'm a Scylla employee, so sometimes when I say outrageous things like, hey, they reduced from 900 nodes to 70, people don't believe me. So I say, hey, just go and watch their presentation. They will tell them yourselves.
Well, we should say, I mean, nothing against marketing folks. You're not a marketing person. You are a technical.
Not at all.
So, you're like, if you're going to say it does this, you want to make sure it does. It's pretty impressive numbers. I mean, frankly, if you just saw those numbers alone, you might think that, okay, under best conditions on a Tuesday night and, whatever, that it can do that. And was it for COMCAST example, was it driven more by the latency or more by just the sheer number of clusters they were managing, or was it kind of ran against both and had to solve it?
I think it's a combination of those factors, but if you think about this problem of node sprawl, right? If you keep adding and adding and adding nodes, at some point you are going to have dedicated people either managing those nodes or writing a ton of automation so they can kind of self-manage. but it's a lot of work. It's a lot of time invested, and well, we're doing everything in our power to leverage those big machines so you don't have that big node sprawl, right? In this case, you can see that there's two metrics there. So it's IOPS, they called recs there for some reason, and latency. And when you compare both, you're going to see that we're delivering exactly what I said: more throughput, less latency. And that's exactly what you want, right?
And they're doing a lot of downstream content delivery, so maybe that's request probably for content, I would imagine. Well, let's kind of talk about then why Kubernetes, why Scylla is a great match for it.
Yeah, again, as you mentioned, I'm not a marketing person, so I'll tell you one thing. Every time you have a bare metal machine, when you add a virtualization layer, it's another level of abstraction. It's going to consume some resources. It can be minimal. You're still losing something. The same thing goes for containers. But we did a lot of research. We have some articles published about the price of containerization. So as much as possible, we want to get rid of everything that can impact performance, but you cannot avoid Kubernetes. People love it. They're running all kinds of stuff in Kubernetes. It started with stateless applications, but of course, if it was so good, people liked it so much that at some point people said, you know what, we should try to run databases or stateful applications on Kubernetes. So at some point we said, you know what, let's dive in, let's make sure it works. And with that, we had, first some experience using just the Kubernetes manifest files. Then we tried with Helm charts, and because it's a database, there's a lot of operator involved on that. You're decommissioning a node, you're expanding your cluster. So we decided to automate everything. So we created a Scylla Operator. So you can run Scylla on Kubernetes and still get the best performance that Scylla can give you on a Kubernetes environment.
Great. I think that's I think one of the things we have kind of coming up, but let's talk about Alternator and what that is.
So again, the Alternator is a lot of people, they're using DynamoDB, they like the product, but at some point, as you scale, it starts becoming a little expensive, right? Because they're charging you per transactions. So we said, you know what, given what we already have, which was the CQL, one of my developers had this idea that, you know what, I think we can implement an API that, would allow people to use their application as if it were Dynamo, but well, on Scylla. And well, there's a ton of advantages there. First, you already have the hardware allocated. You're already using Scylla. You just enable the alternator, which is our Dynamo API. Point your application there. It just works, right? Another advantage is, well, let's say that for some reason you're moving out of AWS, right? You're going to Google. You're going to, I don't know. Or on-prem for security reasons, and then you cannot have Dynamo anymore. Well, now you can. So no vendor lock-in anymore. We still have that better performance that I mentioned since the beginning. We have the benchmarks to back it up, and we are more cost effective.
Another reason too might be, once you go cloud, it's not unusual to go multi-cloud, right? So you're moving across from starting, Azure and add AWS or Google. So that's also, I would imagine, a pretty common scenario.
Absolutely.
Well, let's talk about some of the price performance, and we can dig into, with the kind of numbers you were sharing, we always have to financially justify with someone, usually the boss,
Absolutely.
finance, maybe the executives of the company. Talk a little bit about how you kind of equip people to make that conversation easier.
Yep. And I'll be very honest with you. Usually I'm the guy talking to the technical guys, and they get so excited about Scylla. So they want to use it. Sometimes they come to me, they are already using it. They're doing their own experiments. They have their own lab, but then, well, they need some slides. They need some reports. They need some numbers so they can, talk to the boss and say, hey, can I use this?
Mm-hmm.
And when they see those numbers that you're seeing right there, so for the same workload, for the same number of sheer transactions, for the same data model, everything is there on that link for the benchmark. You're going to see that we are 5 times less expensive. Another point, nobody wants to have, things like hot partitions or, unbalanced distribution on their data, but that happens. And on those cases, you're going to see also in the benchmark, we still deliver that better for performance, and your cluster is not, completely bottlenecked. And well, what I hear from some ex-Dynamo users is that happens there.
Okay, good. Well, and by the way, folks on the webinar, you don't have to write down that URL. You'll have that in the slides when we send that to you too. So talk about deployment options. You mentioned earlier about on-prem, cloud hosted, maybe a little more specifics about how that works.
Yeah, so Scylla runs pretty much anywhere, as long as you're, on Linux. We support Ubuntu, Debian, CentOS, whatever. So I also have one user in France. He's crazy about Gentoo. He's using Scylla on Gentoo and so on. So you can run on premise. You can run Scylla Open Source. You can run Scylla Enterprise. And of course, you can run on any cloud environment. On AWS, for example, we have AMIs. You can just deploy the AMIs and be happy with a cluster in like 3 minutes. And well, lastly, we have Scylla Cloud. The difference between Scylla Enterprise and Scylla Cloud is that if you are using Scylla Enterprise, we are going to support you every step of the way, but ultimately the responsibility of administering the database is yours, right? When you go Scylla Cloud, then we do everything for you. And when I say everything, I mean everything. We install, we configure, we proactively monitor, we run maintenance operations like backups, repairs. If you lose a node, we go there and replace it. You're only going to know that something bad happened because we're going to let you know. But your application is not going to be impacted. So that's the benefit of the managed service, right?
Great. So here's a little bit more about the support you were talking about, some of the options you have, right?
No, actually, this is the alternator support level.
Okay.
As you know, the Dynamo API is pretty big. So these are some things. The items on the left is what's fully supported right now. There is some small portion that it's for if you ask me, for corner use cases that we don't yet support, but it's coming up because the alternator team on Scylla, they are working really hard.
Great. I'm glad you clarified that too. I kind of jumped to the conclusion we're talking about support. You know what? We're into this a little bit. Why don't we switch over and fire up the demo?
Oh, that's a great idea, because
it's
going to take some time. So let's get it started.
Great. Why don't you take over there?
Absolutely. So can you see my screen?
Yeah, looking good. Looking good.
Great. So the first thing that I want to mention is that I already have a Kubernetes cluster running. As you can see, I have a cluster called ScyllaDemo. It has some different node pools here, and these are the nodes that I have. Of course, instead of just showing you things on the command line, I could just come to to the GUI, show you the cluster, same thing that I showed you there. I can show you the node pools. And I can show you, any workloads that are running here. So far, we just have, some stuff that is running on background for, things like provisioning disks, etc. But let's go back. So after that, what I would like to do is start up monitoring, right? So first, let's create a key space. And the reason I'm copying and pasting commands is because usually when people are watching me, I just, I'm the worst typer ever. And I keep, making mistakes. So I thought, you know what, let me just copy and paste and, avoid boring people out of their minds.
Not a bad idea.
Yeah, so the first thing I'm doing here is I'm using Helm charts to deploy Prometheus. This is coming.
Oops, are you still there? Marino. Here's the international part of our webinar. Kind of froze up on us on this end, or maybe my part's frozen up. Give it a minute here to see if we come back. Looks like we aren't so far. Okay, we just had a little glitch there on the internet. Go ahead.
Yes. So I was saying that I'm deploying the monitoring. The monitoring solution for Scylla is comprised of Prometheus and Grafana. I just deployed Prometheus using Helm charts. People that are that are using Kubernetes are very familiar with Helm charts. I can dispense with the introductions. So I deployed Prometheus. Now I'm deploying Grafana. So Prometheus is going to scrape all the metrics from a Scylla cluster, and Grafana is going to give us a nice GUI where we can see all these dashboards, we can see CPU usage, memory usage, so on and so forth. It's taken a little while. That's what we get for doing live demos.
That's where demos go, right? Is this the part that's going to take a little bit to fire up, or
no? This one I was not really expecting it to take a long time. Okay. There's another part that takes more time, but for some reason, let's see what's going on here. Oh, there we go. Great. So let me just see if all the pods are there. Okay, we have Prometheus, we have Grafana. Now what I'm going to do is basically show you that on the browser. I promised you some good dashboards. Let me go there. So I'm basically forwarding the port from those pods on Kubernetes to my own machine so I can show you the monitoring. Oops. There we go. I don't need to change the password now. We can do that later. And then, as you can see, we have the Scylla dashboards here. Right now, there's no data for one simple reason. We didn't deploy the cluster yet. But as you can see, we have everything here. I'll show you after we. So again, back to the operator. So now it's time to deploy the operator. So it's pretty simple. It's one YAML file. You just apply that YAML file to Kubernetes, and it's going to do everything for you. And now we have the operator, and we will discuss it a little bit later. Let me just make sure everything is up and running. Yep, the pod is there. And now let's create a Scylla cluster. Again, I'm doing some, basically setting the region and the zone. I'm changing a cluster YAML file on the fly, and I'm going to create, oops. And of course, I missed this. There we go. Now it's creating a Scylla cluster. It's passing this cluster YAML to our operator, and the operator is going to take care of creating that cluster. So first thing, let's see if the cluster was created. Scylla cluster is there. Nice. Let's see how are we with the pods. And this is what I believe it's going to take a little while. So Mitch, by all means,
Why don't I take it back?
I'll put this here. And you know what? Let me do a little trick here so I can keep an eye on it, and I'll let you know when we're ready.
Okay, good deal. I'll bring back up a few slides we can talk through. And if you just let me know when we want to jump back.
Go for it. Go for it.
All righty. Let's see here if I can manage to capture the right screen. Okay, I think, are we in the right place here?
I think one before, right?
Okay, there we go.
Oh, yeah. So this is what we, remember that I mentioned that, you know, sometimes people come to me and say, hey, just test it with Docker. That's exactly what we're suggesting there. You can run one line, Docker run, you know, enable the alternator. And then on the second line that you can see on this slide, you're basically, you know, creating a table on, you know, our Dynamo API. And after that, you can run an application. You just point it to Scylla, and there you go. So all the folks that are, you know, watching us, I invite you to try it yourself.
Looks pretty straightforward. And then here we go.
Oh, yeah. And this is Dynobase. After you have your Docker container running, the same thing. You can point, if you prefer a GUI instead of running, you know, on a CLI, you can use Dynobase. It's going to work out of the box.
Great, great. Well, just, by the way, just like demos, my camera decided to be a little flaky and drop the background and be weird. So we're just going to roll with it.
Yep.
Okay, good. Right. So we talk about Kubernetes. Talk a little bit about the cluster.
Yeah. So let me explain a little bit what I just did. People saw me doing it, but I didn't give a lot of explanation. So the Scylla Operator is basically a controller, right? You deploy it there, and it's going to, you know, monitor your cluster environment, your Kubernetes environment. And then after it's there, you can tell, hey, go do this for me. So the way we do that, it's through a CRD, which is a custom resource definition. And we create this concept of a cluster. Oh, go figure. It's Scylla and there's a cluster, right? So basically, territory. Yeah, so basically what I did was I created a cluster YAML. I passed that cluster YAML to my operator. And then it starts creating that cluster automatically. After we are done creating the cluster, I'm going to show you that, you know, among the capabilities that we have on the operator, we can expand the cluster, so we can add more nodes. You can shrink the cluster, so you can remove nodes. It's going to do all the maintenance operations that are needed without, you know, user interaction or. And can you go to the next slide?
Here we go. Sidecar.
Yeah, and the way we do that is, you know, every time we deploy a Scylla pod, it's also going to have a sidecar. And well, when you need to run any maintenance operations, what the operator is going to interact with is with that sidecar. That is the Scylla Manager agent. And then, you know, from Scylla Manager, you can, you know, run backups, run repairs, you can do whatever you want. And of course, it's very extensible. We're planning a ton of new features for Scylla Manager, and that is already integrated with our Kubernetes operator.
Mm-hmm. Folks are going to be very familiar with sidecars, of course. Great. So let's kind of put it all together here.
Yeah, so that's the pattern, right? So I told you that there's a cluster YAML. That's a little snippet on the right side, right there. So what am I doing there? Basically, what I'm doing is, hey, I'm specifying a Scylla version. In this case, I'm not using 3.0.6 because it's really old. We're using 4.0. You can see that I pass a data center and a zone on GKE, and it's going to deploy, as you can see, 3 members there. It's going to deploy all 3 members, so 3 nodes. And well, let's say you lose a pod for some reason, right? Then the operator is going to detect, hey, these guys, they're supposed to have 3 nodes, now they have 2, and it's going to spin up a new node, and it's going to replace the old one that was just lost. And again, all of that without any operator intervention, right?
Mm-hmm. Well, let's look at the mappings too then, because I'm sure folks want to know, you know, what maps to what from Scylla to Kubernetes.
That's a great question. So there's this problem with terminology, right? Because each product is using their own terminology, and then people sometimes get all those wires crossed. So that's the mapping that you're looking for when we say a Scylla node. A Scylla node is going to reside in a pod, right? Mm-hmm. On Kubernetes, we have stateful sets. So we are creating stateful sets, 1 per rack, which means in this case on Google Cloud, we're talking about an availability zone, right? So you have the region like US East 1, and you have the availability zone, which is C, right? We have a different stateful set for different data centers. So if you have multiple regions, you can have, you know, a Scylla data center on a different region. And of course, the cluster is the cluster. So you can have one cluster with multiple data centers, multiple racks or availability zones, and Scylla is going to take care of everything for you, you know, high availability, distributing the data, replication, and so on and so forth.
Very good. I feel like we're running a cooking show. Let's check in and see how the demo is doing. Because we're coming up on the demo, but we can talk about some other things. But how close are you, do you think?
Let's see. So give me a second. Can you see my screen? Okay, so basically I told you we were deploying a 3-node cluster. Mm-hmm. I'm just running watch here so we can see the status. And as you can see, it started with 1 node, then it moved to 2 nodes. Now it's creating the 3rd one, but out of 3 nodes, you can see that 2 are ready. So we're basically waiting for the last node to be ready. And after that, we can play with our application. If you want to take back the screen share, go back to the slides. As soon as, you know, the 3rd member is ready, I'll let you know.
Okay, great. Happy to do that. You know, while I'm kind of getting the slide back up and we're waiting for, you know, the cooking to get done here. I'm really curious, kind of going back to the roots and the foundation. One of the questions that we got was, how much of a role did the founders of Scylla, who started the creation of the product, how big of a role did it's in KVM and Linux play? Because I know you also mentioned, you know, it's in C++ and there's some efficiency gains to be had through that. Whoops. Talk a little bit about that.
Well, I think it was fundamental, right? Because they spent so much time thinking about, you know, hardware, about a kernel, how to extract the best performance out of that hardware. Most of the NoSQL products that you see out there, they're great, but people are we live in an era that, you know, hardware is abundant. So as everything that it's abundant, people tend to waste it, right? But those guys, they were constantly trying to squeeze every bit of performance of every part of the system. So when they started creating Scylla, it was only natural that they would try to do the same thing for a database, right?
Well, it makes a lot of sense. I mean, there was a time when, of course, we were very concerned about how much memory and a disk I/O and all those things had when they're in such limited supply. And it seems like engineers, folks that are used to working at an operating system level, even in today's environment where I need another server, just plop down a little bit more money, I get another instance of whatever I'm looking for. You know, operating system developers really do think very, very much about, you know, tight code, efficient memory, efficient processing, you know, reducing the number of inter-process calls across the kernel, things like that.
Hey, looks like we're ready.
There you go.
So as you can see, we have, you know, 3 nodes, all 3 members are ready. So now we can play with other things, right? So let me see. Oh, maybe first, let me show you how we can scale, right? So I promised you I would deploy a cluster, and now we can, you know, just change this cluster. So right now I'm just describing the cluster YAML on Kubernetes. And as you can see, there are 3 members here. So let's scale down. I'll change 3 to 2. I'll save this. Boom. And now if we go back here, immediately we're going to see that we are scaling down. So we're scaling down to 2 members. Very soon this number is going to change. And then, well, as I promised, we can, you know, create a cluster. It's going to expand. So as you saw, we got 1 member, then the other, then the other. So we were adding nodes, and now we're subtracting nodes. It's also going to take a little while, but meanwhile, why not, you know, do something else? So let me see. Let me show you here. So I have a game of tic-tac-toe, basically, but you know what? Yeah, let's do that. So basically what I'm going to do is, in this one I didn't have ready. So now you can see when I do a typo.
Not pasting that one in.
See, I told you, man, every time.
The pressures of demos.
Yeah. Fly, tic-tac-toe. You know what? Even better. I have a script. Let's just run this. Boom. Well, exactly what I was doing before. So basically we're, you know, deploying YAML so we can have a pod, and we're creating a replica set. And now let's check the logs. Okay, it looks like it's working. Let's see if we got an IP so people can play with it. And I'll ask your help to play with me.
Yeah, this is the audience participation portion of the webinar.
Absolutely. So when we get an IP, everybody that is watching us is, you know, invited to go to that IP and play with it.
There you go. Looks like you got one back.
Oh, there you go. And automatically, you know, sent me to the browser. Let's try to create a game. Oh, I need to log in first. So Moreno. Mitch, you can go to the same IP. It's 34.83.44.148. So now we'll create some tables so we can play.
Let's see here if I can get there fast enough. Say the IP address again, 34.
34.83.44.148. It's on the screen.
Oh, gotcha. Of course. It's a little smaller on my screen to see here.
Yeah.
What I'm using.
And then just let me know what is the user that you're using to log in.
Okay. It's taking just a minute for mine to load up here.
Well, meanwhile, let me show the audience that now we have, you know, data in the monitoring. as I mentioned before, we can look at a different dashboard maybe so people can see. Yeah, so as you can see, we had 3 nodes first, and now we have 2. So one of them left. Were you able to log in?
Just looks like, for whatever reason, I'm not getting there on my end. I'm not sure why.
Oh,
this is interesting.
Weird.
It is one of those internet days, I think.
Yes, it is. We had so many, you know,
here we go.
Instability, right?
There we go. I got there.
Oh, nice.
Logged in as Mitch, M-I-T-C-H.
All lowercase. First,
yes, capital M.
Mitch, like this.
M-I-T-C-H. Yep.
Perfect. Create a game, and now you can join the game. Okay,
games in progress. So I currently have no games in progress. Let's see. Oh, here we go. Invitations, accept from Moreno. Oh,
there we go.
Test my gaming skills here. Okay.
So let's start.
My turn. All right. Well, I'm going to grab that center.
Okay. Let's do this.
So besides just a really interesting game of tic-tac-toe, tell us what's going on here in the background.
Well, so basically we are, well, first we're running everything in Kubernetes, right? Mm-hmm. Second, this application, this game of tic-tac-toe, it's running on the Dynamo API. So, I can show you here that, you know, let me change the monitoring. You see that there are some requests going on. This is us playing and the audience is playing, and here we are.
Excellent. Oh, very nice. I guess, well, I won that one, so I started another one.
Well, we can play again.
I think I've exhausted my tic-tac-toe skills. No, it's a lot of fun. It's very interesting. You want to switch back then, and we have about 10 minutes or so to
Absolutely.
Work on things. So why don't I grab the screen back? Is that okay?
Absolutely. Go for it.
Great. And get the right screen here.
Okay. I can see there are more people playing the game, so that's good.
There you go.
Have fun, guys.
We like that. Have fun. Okay, so this is just kind of the setup of what was involved with the demo that you're showing, and and there's demo code you can get on your website, correct?
Yes, absolutely. And we try to automate everything. So for people to have the same deployment that I just showed, it just, you know, like 3 or 4 scripts that they have to run, and they will have, you know, a Scylla cluster, a Kubernetes cluster, a Scylla cluster running with the Alternator API. We'll have a game to play, so an application to play with. And of course, let me mention, as I said before, we are open source. If you want to make improvements to our game, by all means.
You want to turn it to a massive multiplayer online game. There you go. Have fun. Have at it. So
well,
let's talk
it's not like people are you know, don't have extra time during, you know, these trying times, right? So
COVID gaming time. Well, there's a lot of that going on too. So yeah. So we're going to jump into status here. Talk a little bit about what state of things in with the different offerings that you talked about.
So basically, the alternator is already considered production ready on Scylla 4.0. It was experimental for a while. As I mentioned before, there are still some small features that are not there, but they're coming up. Of course, if you have any urgency on one of those features, feel free to drop by on our GitHub, you know, open an issue or a feature request. We're glad to work with the community. Again, people can deploy on Docker, on an AMI, on AWS, on Scylla Cloud, and as I just showed you, on Kubernetes.
So this is a good place. One of the questions that we have from our participants, the audience here, they're asking sort of what's the difference between the open source and the enterprise version. Sometimes companies sell support, and that's the big difference. And yes, other times it's scaling, like, you know, enterprise HA kind of features. What is the sort of difference between?
We don't put a cap on Scylla Open Source at all. You can use as much as you want. You can scale as much as you want. But of course, first, the open source product is where we put our bleeding edge, right? So it's more prone to being a little bit unstable, even though we QA and battle test it as much as possible. Bugs are just a part of life. Anyone that is in the industry knows that. Scylla Enterprise has a bigger release cycle, so we test it more. We do longevity test. We put it on hundreds and hundreds of nodes, really big clusters to make sure we're catching every bug possible. With Scylla Enterprise, you get, of course, support. You get a dedicated Slack channel for your company or for your employees. We are there all the time. We advise you on data modeling, on best practices for Scylla, best practices for an application that it's connecting to Scylla, and so on and so forth.
Great. Let's move to Operator. You want to talk a little bit about that?
Oh, yeah. I mentioned the Operator. As I told you, we have a bunch of scripts there so people can try it. We have a GitHub repository. It's right there. People are going to get the slide, so no need to write it down. We have the documentation for if you want to run on your Minikube, Kubernetes on your own laptop, you can do that. You can go, if you want to go to a cloud environment, or if you have your own company Kubernetes, you can use all of them and play with Scylla.
Okay, excellent. Here we go, talking about.
Yeah, that's the things that I already mentioned. You can bootstrap, downscale, outscale. We're going to manage all those maintenance operations for you. You can use the Prometheus and Grafana with Helm charts, so you can have the monitoring. It's secured. That's pretty much it.
Okay. Let's see. Scylla on K8s. Perhaps we talked a lot about that.
Yeah, one of the things that are coming up, it's this multi-data center support. It's usually let's call it a Kubernetes limitation. Sometimes people have a hard time connecting different data centers on the same Kubernetes network, or federating between different cloud providers or Kubernetes providers. We are seriously considering, auto-scaling features because it makes a lot of sense with Kubernetes, right? The Scylla Manager integration is already there, and we are planning to also publish some benchmarks, some more manuals, because right now you have instructions for running a Minikube and GKE. We also want to publish it for EKS and AKS on Azure, etc.
Sounds like a lot of stuff in the works. Good things. I did notice too, there's a lot of really good information on your website. I didn't go through all of it, of course, but things on benchmarks and of course getting started and using Scylla.
Yeah, that's one of the things that I'm very proud of. It's our benchmarks. We're very transparent. We published the entire methodology. You can reproduce it yourself. You don't have to believe us. And everything's there. Everything that you need, the machine types, the commands that we're using, the configurations. If we did tuning to a competitor, you can see exactly what kind of tuning we did. So I love being at Scylla because we are very transparent. We're very honest. So.
Well, speaking of that, I guess people can reach you directly, right? Reach out and talk to Moreno.
Yes.
Ask your questions. One way certainly is email.
Absolutely. You can send me an email, but well, I'm just one person, and then, well, you end up with just one node, and it's going to be bottlenecked. So Scylla is a distributed company. We have people all over the world. There's always someone that is awake. So my suggestion is that people go to our Slack channel. So we have a Scylla Slack channel there. People can go there. We have more than 2,000 users on that community. We have all of our engineers, all our support people, all the architects, including me. So if you have any questions, by all means, reach out.
That's nice too. Then you've got some continuity as things get hand off through the hours of the day and kind of move.
Absolutely.
Follow the sun, as they say.
Yep.
One of the questions I want to ask too, and this actually came up in the questions from the audience, is usually you kind of have to architect things to be able to scale them. Like, okay, how am I going to handle a large number of Kubernetes clusters? Mm-hmm. And when you're going from large numbers of clusters down to a smaller few, is there sort of a reverse architecting that you have to do, where you have to think about things differently of what goes into a cluster and the architecture of them? What are some of those kind of mental gymnastics you have to do to think about this in a different way?
If you ask me, every time a customer asks me a question like that, I tell him, hey, always go with bigger nodes, just because it's going to save you a lot of headache, a lot of maintenance, a lot of investment of your own time. But humans, we are wired to avoid change as much as possible. Some people are used to using, big clusters with a lot of nodes. You can stay the same way if you want, but again, a lot more work, okay? It doesn't really make a difference for us, because it doesn't matter if the node is small or big, we are going to use all the resources. So if you have 3 nodes with 10 CPUs each, that's 30 CPUs, right? Mm. Well, you could have 10 nodes with 3 CPUs. It wouldn't make much of a difference for us. We are still using 30 CPUs, and it's still distributed. It's still highly available, right?
Okay, interesting, great. Another question we were asked is, the audience wanted to know, can you tell us a little bit more about what some of the steps are you need to go through to drop Scylla in place of like Cassandra?
Oh, it's pretty simple. So ScyllaDB.com/downloads, everything's there. You can apply for Scylla Enterprise for 30 days, or you can use open source. Usually we have packages for the Linux distributions. So if you're on Ubuntu, it's basically install repository, run apt install Scylla. There you go. The instructions are also there. One of the things that Scylla does, it doesn't matter where you're installing Scylla, right? If you're installing on-premise, on Kubernetes, on cloud, one of the things that Scylla is going to do is benchmark your hardware. Remember that I mentioned that we leverage that hardware very good. Mm-hmm. One of the reasons is because, well, when you install Scylla, we're going to investigate, hey, where are we? What kind of machine is this? How much CPU do I have? How much memory do I have? How much disk? How fast are those disks? How many interrupts can I use? And so on and so forth. So that's one of the reasons Scylla is always going to give you the best performance out of the box, because first we investigate that hardware, and then Scylla does its magic.
So instead of leaving all the tuning up to you, at least establishes the profile and works from there.
Yes, exactly.
Well, we're getting close to our wrap up here. Thinking about what your role is, question that occurred to me, here's your opportunity to help every person who's going to use Scylla. What is some guidance you would have as sort of best practices for helping people get off on the right foot, getting started in a good way, so that someone like you doesn't have to come in and help them sort of like rethink something or start over?
Well, the first one would be to use our community, to reach out, talk to people. There's a gazillion of different use cases that you can run on Scylla. If you're in doubt if Scylla is a good fit for your use case, just ask. If it's not, I'll be the first person to tell you, hey, this is not a win. So go try something different. Other than that, because control theory dictates that, you know, this lowest part of a distributed system is, it's going to be the speed of the entire system, right? So today, it's usually the disks. So with Scylla, the better the disks, the better it's going to be your performance. So try to stay away from hard disks, spinning disks. Try to use SSDs and VMEs. And if you have a bunch of them, use a RAID 0. That's one piece of advice that I give to everybody that comes to Scylla. But of course, that is when you're, you know, seeking for the performance. If you're just playing with it, any machine will do. You can run on Docker and, you know, have tons of fun.
Well, and that's the nice thing about the cloud is you can step up from, you know, spinning disk to SSD, and as you need those additional capabilities, right?
One more thing I should mention is that we have Scylla University. So if you're new to Scylla, you want to learn, you know, basic concepts, you want to, you know, learn data modeling, how to, you want to be a DBA for Scylla, you have tons of courses there, and people can, you know, just learn. And again, if you have any questions that are not there, just ask on Slack.
Excellent. Well, we are right at time. So thank you, Moreno, for great conversation, showing us and sharing some of that knowledge that you have about Scylla. And of course, we want to thank the audience too for your excellent questions. We're giving away our gift cards, but just to save some time here, our folks at DevOps.com Media Ops will reach out to the winners of that. So we'll hand out those gift cards. So if I could ask, also be sure to check out DevOps.com. There's lots of great webinars just like this one coming up. And please join me in thanking Moreno Garcia, who is solution architect with Scylla. Wonderful job, Moreno. Really appreciate it. I had a lot of fun talking to you today.
Me too. Thanks a lot, Mitch. I hope we can do it again. There's, you know, lots of different features. Let's do it again for other features.
I feel like we kind of scratched the surface of some of the things we can do with Scylla. So I'd love to explore that with you another time.
Absolutely.
Well, we of course would like to thank you, our audience, for participating. You know, your time is super valuable to take an hour and spend it with us to talk about Scylla and database.
Absolutely.
Cloud. You know, we value that. We're honored that you spend it with us. So,
and they are still having fun with tic-tac-toe.
Well, they're still going. They're still going. Well, good. I'm glad that's been entertaining. We've hopefully, you know, brightened the day a little bit. So it's been my pleasure hosting today's webinar. Thank you for joining us. Be safe, be well, and be careful out there.